Okay, Assalamualaikum. Now we are in our second class, second year. Actually, we are going to continue from last week. Do you hear me clearly or putus-putus?
Clearly, sir.
Yes, sir.
So better than last week, right?
Yes, sir.
Yes, sir.
So you want me to go through the overview or sepintas lalu lecture yang last week punya? Ataupun
Boleh, sir. Boleh, sir.
ataupun you clear yang last week punya? Your choice.
Last week, sir.
Last week
Boleh,
punya, okay.
sir.
Okay.
Okay, sir. Boleh, sir.
Okay, let me put in the slides. Okay, I'm going to share the slide. Okay, can you see the slide? System.
Yes, sir.
Okay,
Nampak, sir.
so this is actually, we have gone through last week, but maybe because of the sound quality was not that clear. So I'm going to go through once more, but maybe a bit brief compared to last week, this chapter 1, and also to complete this chapter. So the introduction, basically that last week we talked about what is a signal. Signal is actually a physical quantity that varies with time and may contain some information. So signal can be an electrical signal, can be sound wave, speech, can be electromagnetic wave, can be radiation also can be a signal, right? Can be an image also is a signal. So in these slides, we have an example of two signals. One is the air pressure wave between 60 to 60 hertz to 7 kilohertz. The output is actually a human voice. Another example is the radio signal. So electromagnetic wave, which normally between 3 kilohertz to up to 300 gigahertz. So the output is actually a radio signal. Okay. So how to and this signal is actually you have is a part of a system, right? So you have an input signal and you have an output. And what is a system? System is a signal processor which either to modify the signal or to extract information from the received signal. If we take the example just now, the speech, the human voice, okay, it has for this example is actually about the production of human voice. Basically, the air from your lung go through the diaphragm and it vibrate the vocal cord and go through your mouth and tongue to produce the voice, the sound. So that is actually a system where from the air from the lung as an input go through the human body with the diaphragm, mouth, and tongue as the systems, and the output human voice. Another example for radio wave, basically that have a transmitter, which is to transmit the signal through the air, and you have a receiver to receive the signal and reproduce the audio, for example. Okay. So an electrical engineer basically deal with electrical signals, which is involve voltage and current. So electrical engineer basically that take any other signals and convert into electrical signal, voltage and current. and do the processing. Okay? So the other signals can be the temperature, vibration, pressure, voice, and whatnot. Okay? So if we take the example of microphones, the sound wave will go into the microphone and will vibrate the diaphragm and produce the audio signal, which after that maybe you transmit through the air. So these are things that you do in electrical engineering, in communication engineering, for example, right? So this is a systems representation. You have the input signals. It x of t is a function of t. The input signal can be many inputs or can be single inputs. And you have a system go through a black box, which is called a system, and you have the output signal. Can be a single output, can be multiple outputs. We call it a response y of t. So a systems you can have is either single input, single output, SISO, SISO, single input, single output. You can have multiple input, multiple output. This is MIMO, MIMO, multiple input, multiple output. And you can have also single input, multiple output, basically SIMO. You can also have multiple input, single output, MISO. So those are the 4 types of systems. If we characterize it in the form of number of signals and number of input signal and number of output signals. Okay, there are many other characterization of the systems. In this course, we are going to learn about LTIC systems, which is at the end of this chapter. We will explain what is LTIC. LTIC is basically that linear. L is linear, T is time, I is invariant, C is causal. So in this class, we learn about LTIC systems. Last lecture saya tak ada sebut benda ni lagi kan? Betul tak?
Betul, sir.
Lain sikit. Lain
Betul,
sikit saya punya lecture, different days, different lecture. Walaupun slide-nya sama. Walaupun slide-nya sama, saya punya lecture is different because I don't have what do you call it, script. It's all from my mind. I talk from my mind.
Terbaik, sir.
Baik, sir.
So that's why you have to attend the lecture, because not necessarily what I say, what I presented will be the same as in the slides.
Betul, sir.
Okay. Now we go into type of.
Yes.
We are going to cover 8 types of signal, which is analog versus digital, deterministic versus random, periodic versus non-periodic, even versus odd. Okay? So analog signal is basically that where the amplitude is continuously defined. Right? So that is an analog signal. So it's a real number, not a discrete number. Right? So for example, if you look at the graph, f of t, the analog signal is basically a continuous waveform, right? So at every point in the on the time scale, you have value. For example, in that scale we have 0, 1, 2, 3, 4 until 12. So at 0.5 also you still have value. At 0.1 also you have value. So that is continuous. So amplitude continuous, that is an analog signal. Whereas for digital signal, the amplitude is discretely defined. If you look at the graph, on the time scale you have 0, 1, 2, 3, and 12. So the value, the amplitude is only defined at a constant interval. But at 0 you have value, 1 you have value, but not 0.5. So that is the digital signal. So amplitude is discretely defined. So analog versus digital signal is identified based on the vertical axis or the amplitude. Okay, so that is analog and digital. Deterministic and random signal. The identification is based on the pattern of the signal. Pattern. How do you define a deterministic signal? Basically, the pattern must be predictable. You can predict what is going to what is the value next. The next value you can predict. Whereas for random signal, pattern is not predictable, as shown in the diagrams there. Right? So, for example, like the white noise, noise. So the pattern is not predictable for white noise. But there are some noise that is predictable, depending on the what call it source of the noise. Okay. Another type of signal is periodic versus non-periodic. For periodic signal, it has a repetition. It's repetitive. So therefore, it has a period. For a repetitive signal, it has a period. It has a frequency of repetition. So periodic signal is, for example, let's say f of t equal to f of t plus capital T plus the period. And it's also equal to f of t plus n of t. So it's repetitively n times. And the frequency calculate as f equal to 1 over t, 1 over the time period. And the unit is in hertz. Or if it's in omega, 2 pi f is equal to 2 pi over t. Units is radian per second. For non-periodic signal, it's not repetitive. There is no repetition of the signal. Right? So there is no concept of period. So the identification is based on the repetitive of the signal. You have to recognize whether the signal has a repetition or not, in order to recognize whether the signal is periodic or non-periodic. The last one is whether the signal is even or odd. So in order to recognize, to identify whether the signal is even or odd, you look at the symmetry of the signal. Okay. If it's symmetry with respect to the vertical axis, there is an even signal. So the properties of a symmetrical signal is that f of t is equal to f minus t. F of minus t. So the signal is actually reflected. The mirror image is under with respect to the vertical axis. For the odd signal, it has a double symmetry, which is first one is symmetry with respect to the vertical, then it's symmetry with respect to the horizontal. Right? So therefore, in mathematical form, we can write f of t is equal to minus f of minus t.
Sir.
Okay?
Sir.
Yes.
Sir dekat slide yang mana, sir? Saya terlepas,
Even,
sir, sebab suara saya macam sangkut-sangkut sikit, sir.
Sangkut lagi. Even and odd. Signal, even and odd.
Even and odd. Okey je ni, San. Okey.
Semua ada.
Okey.
Clear.
Betul, boleh, betul. Okey, clear, sir, clear.
Kita tertidur tadi.
Maksudnya San tidur. Dah makan.
Jom kita tandas.
Terbayang
tandas
nasi
tadi.
goreng kambing, sir.
Okey, dimaafkan. Now we go into basic function. Basic function, which is you have unit impulse, unit step, ramp, sinusoidal, exponential, and sinc. Okay, unit impulse or Dirac's delta function is represented by an arrow, and is written as delta of t. That is a unit impulse. When we write delta of t, you should know that there is a unit impulse. And as shown in the diagram, it shows as an arrow. Why it shows an arrow? Because the amplitude of the unit impulse is actually infinity. So a delayed unit impulse we write as delta t minus tau. An advanced unit impulse we write as delta t plus tau. So the plus tau is actually here. Not actually located at a time equal to minus tau. Delta minus tau is actually located at times equal to tau. Right? So this is actually a delayed impulse. This is a advanced impulse, delta t plus tau. Right? The next function, basic function, is unit step. Unit step is represented by u of t. A delayed unit step is u t minus tau. Yeah. So basically that it starts to be non-zero. It starts to be 1 at time equal to tau. Once unit step, u t plus tau is when a signal is 1 at time equal to minus tau. So unit step is basically 0 before before minus tau and 1 t up t plus tau if it's a advanced unit step. If it's what we call it delayed unit step, it's 0 before tau and 1 after. Clear that?
Clear, sir.
Another one, the third basic function is unit ramp.
Right.
Unit ramp function is represented by R of t. A delayed unit ramp is R t minus tau, and advanced ramp is R t plus tau. So unit ramp is basically that you have a slope here. It's a increasing. It's an increasing function. Linear. Sinusoidal. Sinusoid basic function is basically sine or cosine. If it's in the phase domain, we write as a sine of theta or cosine of theta, which is sine of theta is equal to cosine theta minus pi over 2. If in time domain, we write as sine omega t, which is equal to cosine omega t minus theta. Right? So this is sinusoidal, and of course this is an exponential. It's f of t is equal to a e to the power of bt, where a is the amplitude and b is the rate of decay or rate of growth. Minus is rate of decay lah. Kalau positive is rate of growth. Right? So this one actually you have learned before. And another one, this is a complex exponential function where you have a combination of the exponential function and the sine. So this is what I said just now. is what we call it, if B is minus, which is for this example, B is -2 in this example. So therefore, the signal is decaying, exponentially decaying. The sine wave, sine 10 pi t, actually decaying with the rate of e to the -2t. Whereas the next function, which is f of t is equal to e to the power of 2t times cosine 10 pi t, is actually a cosine which is growing at the rate of e to the power of 2t. Okay. And the next one, the last basic function is the sinc, which is sinc is defined as sinc of sine of t, sinc of c of t is equal to sine of t over t. And this is the signal shown in the diagram. Okay, any questions so far? It's very simple at this moment.
No, sir.
Okay, now actually we go into the operation of the signal. This is actually where we stop last lecture. So this is an operations on signals. There are 4 types of operation on the signal that we can do on the signal, which is time shifting, that you shift in terms of times, time reversal, time scaling, and a combination of those 3. Can be a combination of time shift and time reversal, can be a combination of time shift and scaling, can be a combination of reversal and scaling, or it can be a combination of all 3. Okay, so a continuous time signal FT can be changed from its original form using this signal operations. So we can reshape your signal based on these 4 types of operations on the signal. The first one, time shift. Time shift is basically that an operation based on the moving the whole signal along the time axis by a constant. So this is we talk about delay. So when you talk about time delay, we talk about the time. So y of t is equal to x of t minus t naught. T naught is the delay or constant. So where x of t is the original signal, y of t is the time shifted signal. It's the result of the shift. And t naught is the constant, or sometimes we call it a delay. For example, you have a signal shown there, which is x of t, where at -2 is equal to -1 up to 0. Then after that, at t equal to 0, x of t is equal to 3 until to time is equal to 1. Then after that, it's constantly reduced from 3 to 0 at t equal to 3. So this one, right? Yeah, this is the original signal. Okay. Yeah. Then this is the shift operation. For this example, we shift by -3 t minus 3 by 3 seconds. So we delay by 3 seconds. So this signal is basically that can be written as y of t is equal to x of t minus 3. So at t equal to 0, so 0 minus 3 is really equal to x of t minus 1. But at t equal to at t equal to 0 just now. What did I say? T minus t is 0. If t is at equal to 0, so 0 minus 3 is at the value is equal to x to minus 3. So at minus 3 is the value, original value was 0. So 0. Y of t is 0. And t is equal to 1. So y of t is equal to x at minus 2. So at x2 minus 2, this is the value. Minus 1. So therefore, this is the value. That t equal to 2. Here. So it's somewhere here. So basically that it shifted by 3. So this shifted by 3. Here. Delay by 3 seconds. And this is an example of advance by 3 seconds. T plus 3. So instead of minus 2 at minus 2 seconds, it start at minus 5 seconds. So this signal is basically that shifted. In this case, this signal is shifted this way to be that. And in this case, the original actually shifted this way to be this. So this is actually the operation of time shift.
Sir,
Siapa apa ni on mic tu?
sir.
Ada soalan?
Ada.
Okay.
Kenapa kalau delay time shift graf tu bergerak ke kanan bukan ke kiri?
Delay. Okay. Gerak ke kanan because for example. Inilah. Kelas start pukul 10.
Oh.
Tapi you datang pukul 11.
Alamak.
Maknanya you delay 1 jam. Maknanya dia shift ke mana time tu?
Oh, faham.
Depan.
Ke depan.
Kalau
Betul,
kelas
sir.
start pukul 10, you datang pukul 9.
Style,
So maknanya you advance 1 hour. Okay? Clear?
Yes,
Clear,
sir.
sir, betul.
Clear.
Okay.
Clear,
I
sir.
give you a very simple answer.
Penangan kambing saya.
So basically, if you want to talk about time shift, you talk about kalau you lupa lah dalam exam, you blank. Macam mana? You ingat example yang saya bagi.
Baik, sir.
You datang lewat kelas. Itu maknanya, oh, okay. That is it. Time reversal. Time reversal is basically that operation is based on the mirror. At the vertical axis, and basically that the formula y of t is equal to x minus t, and y of minus t equal to x of t. Basically, where you reverse the time. If the time is positive, you make it negative. If the time is negative, it positive. So x is the original signal and y is the time inverted signal. So let's say this is the signal, the same signal that we emit that we used before. This is the original signal. Then time inverted signal is basically that you make the time is negative, x of minus t. So, for example, at 0, okay, first basically we start from here. At time is minus 2. At time minus 2, the y of t is equal to x of minus 2. So, y of 2 equal to x of 2. Here, okay, at So actually, if we draw, we can start from here. Then you can plot. But this case, basically that it use here. So basically that y of 2 is equal to x minus 2. We just take the value of here, which is here, and here. So t is 2. At x equal to 0 is the same as x of at y of 0. So this value stays. This value stay. Then after that, this t is equal to 1. If t equal to 1, y of 1 is equal to x to minus 1. So what is the value of minus 1? It's actually here, 1. So it's 1. Or actually it takes this value. This value. 1. Okay. And at what? At t equal to 3, it takes the value of minus 3. So it's actually reverse. So this value. So actually, this is what happened to the time reversal operation. Okay. So it's actually a mirror image at the vertical axis. Clear?
Yes, sir.
Okay. This one actually
Yes,
you
sir.
can do on your own. Any other signals? Okay. And do time scaling. Time scaling is based on the divide the x-axis with a constant. Actually, to me, it's either divide or multiply. It's not only divide; it can be multiply.
Multiply, sir.
Multiply or divide can be both. Which is if A. So this one is actually I should change to multiply to have what call it a more what call it a more accurate what call it representation. So the operation is based on the multiplication of the x-axis with constant. If a constant is larger than 1, basically the signal is compressed. And if A is less than 1, the signal is expand. So let's say the same similar signal that we take, the similar shape of the signal, the only signal is what do you call it? Is a bit compressed. So if we take 0.15, ini okay. If okay, or they use the y. Okay. If the original signal is y1 of t, so time scale signal, if y2 of t is equal to y1 of 0.05t, so therefore, this is the shape of the signal. For example, if we take at minus 1, multiply by 0.05, so it's 0.05. So this one actually, okay, they use, this is actually the convention is a bit, So this 0.05 is actually it's not A. A here is actually 1 over 0.05. So I should make it this slide clearer. So I will modify this slide for you to give you a clearer understanding. So 0.05 actually is not A, it's 1 over A.
Yes, sir.
Okay. So this 0.05 is actually 1 over A. So then it will fit into this this definition. Because when A is okay, wait. So this is actually this slide is a bit confusing. 0.05. Okay. So this is A is 0.05. 0.05 is here. Okay. So I should change this word. Okay. So 0.05 is A is 0.05 times T. So it's not minus T here. This actually should be divided by 0.05. Then it's expand. Okay. Y of T at T is equal to minus 1 at T equal to minus 20. So we take the value of Y of T of what is the value? Where? T. Siapa yang faham this slide? Siapa yang boleh explain this slide?
Saya kurang faham.
Kurang faham? Okay. Ini saya nak kena nak kena ada whiteboard ni. Nak kena draw. So Y of T is equal to X A of T. So in this example, this is actually X of T lah. The function X of T. So if A is equal to 0.05, so let's say at T is equal to 0, take the value of 0. This is correct. Okay. At T, let's say at T equal to 10, therefore it is actually 10 times 0.5, and 0.05 is the value at multiplied by 10 at 0.5. So it should take the value at 0.5 somewhere here. Okay, so let's say we take here. This actually it takes the value of 0.5 there. Okay? If Y of T at 30, T equal to 30, so 30 times 0.5, 0.05, what's the value?
1.5.
So it takes the value of 1.5. So it takes the value of 1.5. It takes this value. Okay. So we got that. Then at T equal to minus 20, let's say T equal to minus 20, So minus 20 times 0.05, what is the value?
Minus 1.
Minus 1. We take this value. Okay.
So if we divide it,
So basically, this is actually is not divide. It's actually multiply. Multiply. Okay. So you multiply by a constant. Okay, not divide. So I will what do you call it? Edit these slides. So the operation is actually based on the multiplication of the x6 with a constant. Right? So basically, I just change this word, then everything will be the same lah. Clear? Just
Clear,
multiply
sir.
by constant. Okay?
Clear, sir.
Huh?
confused answer.
Confused?
Oh,
So which area that you're still confusing? Still confused?
okay, we know that
Soalan ni, sir.
0.05.
0.05 is an A. Is a constant.
We must divide it. Multiply it.
Multiply.
Yes.
Oh, 0.05 tu dia bagilah sir.
Multiply. But that is a constant.
So bila constant dia kurang daripada 1, sini dia expand lah. Macam tu je kan, sir kan?
Yes.
Oh, okay, faham.
Let's say we'll take A is equal to 2.
Tu.
Let's say you take A is equal to 2. So we start with starting from T. Let's say we take this original signal and we just draw A is equal to 2. So Y, like let's say at minus 1. At T equal to minus 1. Somewhere here.
Minus 1.
At minus 1. So minus 1 times 2 is
Minus 2.
Minus 2.
minus 2. So Y1 at minus 2, what is the value? 0, right? So 0.
It becomes smaller.
Yes, 0. Then at 0 is
0,
bigger.
0.
0.
So 0. So at 0, what is the value? Here, bigger. So still the same. So basically that, let's say if we draw here, so this is actually this. So basically it actually compressed. It's actually somewhere like that. Here, right? Then after that, let's say at 0.5, at t equal to 0.5. So here, somewhere here, t equal to 0.5. So 2 times 0.5 is
1.
1, right?
Yes.
So what is the value at 1? Somewhere here, this. Right? So basically, it's actually starting to drop somewhere here. Right? And what is t at t equal to let's say 1.5. T equal to 1.5?
3, sir.
3. So what is the value of 3 is 0. At 1.5, let's say here it's already 0. So basically that is compressed. It's compressed further, this one.
Oh,
Okay. So basically you have to do that. Okay? You can do this using what you call it a different shape of the signal, right? Or you can show by using MATLAB. You use the MATLAB and try to generate time scaling signal. Anybody knows MATLAB?
Yes, sir.
Then you can try to play around with the figure, with the what do you call it, and visualize the time scaling, time shifting, and all this use the MATLAB. Okay? So the combination of time reversal, time scaling, and time shifting. So if the original signal is x of t, find the transform form of x of y of t is equal to x a of t minus t naught. So three methods can be used. So let's say that this is actually a combination of time shifting and time scaling, and also time reversal if a is a negative number. Okay, clear? If a is negative number, it's a time reversal. So method one, first you shift x of t by t naught, because this is the shifting function. Then you scale the shifted signal by a. So first you shift, second you scale of the shift. Okay, there is method one. Method two, you scale. You scale first by a, then you shift by t naught over a. Okay. Method three, you plot the original signal by replacing t with tau. Then consider tau is equal to at minus t naught. Then solve for t equal to t over a plus t naught over a. T naught over a. Then you plot the t-axis and plot y, t on t-axis. So this method. Okay. So basically that if you use method one, let's say that you need to plot the signal. This is the original signal. Okay. So you shift x of t by t naught. What is t naught here? Minus 1. So you plot of t minus 1 first. So basically that this signal is shifted by 1. So something like this. That is a shifted by minus. So this is the first operation. You shift the signal. Second, you scale by A. You scale the signal by A. Okay. What is A? Is minus 2.
Minus 2.
So you scale. In this case actually, what it does is using the time reversal first, because it's a minus sign. It's a time reversal. So it reverses from the original signal. Okay. If you look at Wait. If you look at this is actually the shifted signal. Then it time reversal. So it reverses the signal with respect to the x-axis, with respect to the y-axis. So you get this. This is the function of reversal, inversion. Then it starts scale with the A. So A is
Tapi
big,
dia
A
device
is
ke?
greater than 1, so therefore A is a compress. So that's why it become compressed.
Smaller.
Yeah.
Betul smaller.
Any question?
No sir, betul sir.
So basically that here.
Sir,
This is
bukan
the
kalau A
original
dia
signal.
kurang daripada
Then you do the shifting by -1. After that, after shift, you do the reversal. So basically you flip with respect to the y-axis or x-axis in this case. Then you scale because it's the A is greater than 1. I mean the magnitude is greater than 1. Therefore it compress. Okay.
Sir,
Yes.
bukan kalau A dia kurang daripada 1 dia expand ke sir?
Kurang daripada 1.
Ha.
This A dia kurang daripada 1 kita ni magnitude. We are talking about magnitude.
Negatif 2.
Magnitude. Negative 2, magnitude is 2. Negative sign is the flipping, the inversion.
Okay sir,
Okay.
okay sir.
You look at A as the amplitude. If the amplitude is greater than 1, what happened?
It compress.
Compress. If the magnitude is less than 1, is expand.
Yes sir.
The minus sign in front indicate the inversion, the reversal.
Okay.
So that's why here, this is the reversal, inversion. Yeah, that's the inversion first. Then you do the scaling. Okay.
Okay sir.
Now this is the method 2. Same function. It scale first. Okay. Now you look at it scale with the magnitude of A. Okay, here. It's -2, but it scale first. Scale. So the value is A is the magnitude of A is larger than 1, so it's compressed. So from here it compress. Then after that it will do the shift. Probably that it will do the reversal dulu. So now it does the reversal. Second step actually reversal. So from this step, okay, it reversed to become this shape with respect to this axis. Okay, so this because sign minus e. Okay, then it will do the shift. It will shift this by how many?
-1. -1. 1/2.
Okay, so it shifts. Okay. Okay, it shift by this total. Okay, this. So tau over A. So it shift by half second. Right? Method 3. This is the method 3. Same signal. So the first one that you solve for tau. You take the tau is equal to minus 2t minus 1. So t is equal to minus t over 2 minus t equal to minus tau over 2 minus 1 over 2. Then you solve for t. Okay. Then after that you plot. Okay. So this one you can try on your own. So basically that from the original signal, which is this one is actually the t-axis replaced with tau. So you plot you write as x of tau in a function of tau. So this is the signal. Then after that, you solve for t and you plot the t-axis. Okay. So this is the method 3. Then you plot the y-axis. Y of t on. Then you plot, it's actually here, yeah, plot the y-axis, y of t on t-axis. So you get this. This is really from this here, this one. Here, this, then you plot the y of t. Okay. This is okay. That is actually on the operations of the signals. Next one, this is the last part of this chapter, is types of systems. This is what I mentioned about LTIC. So the system is causal systems, linear systems, and time invariant systems. So these are the systems that we are going to deal in this course. Okay. System classification refers to how the system interacts with the input signals. Yeah. The interaction can be linear or non-linear. So in this course, we deal with a linear system instead of non-linear systems. The systems also, the interaction can be in time varying or time invariance. And in this course, we deal with time invariance. And the interaction can also be causal and non-causal. And in this course, we deal with the causal systems. What does it mean by linear, time invariant, and causal? We see later. So systems that are both linear and time invariant, with LTI, are great interest because they may often be described sufficiently well by a certain single input output pair. So normally that from a complex systems, we try to model as much as possible to be linear and time invariant, so that we can simplify the calculation, the analysis of the systems. So causal systems. A causal system is a system whose output is 0 until an input arrives. If there is no input, then the output is 0. That is the causal system. You have to have an input to cause an output for the system. So if x of t is equal to 0 for t less than t naught, then y of t is equal to 0 for t less than t naught. So it means that if there is no input, there is no output. That is the causal systems. You must have an input in order to have an output. Simple. Okay? That's the definition of a causal. Right?
Right, sir.
A linear system. A linear system is that the output for a linear system is proportional to the input. So if you scale an input by A, the output is also scaled by A. If an input is scaled by B, an output also scaled by B. That's it. You have a system of 2 inputs and 2 outputs. So X1 will produce an output of Y1. Input X2 will produce an output of Y2. So therefore, a combination of A X1 plus B X2 will produce an output of A Y1 plus B Y2. So that is a linear systems. Right? So the output is scaled proportionally in time invariant. Time invariant system basically that systems where if there is a delay in the input signal and that delay is also into an output signal. So we'll produce a shift in the output signal. So x of t minus t minus capital T will produce of y of t minus capital T. So a delay of t will produce a delay of t in the input will produce a delay in the output with the value of t. So if you delay the class by 30 minutes, start the class to end class by later.
Oh, faham.
Okay. So this is time invariant. But sometimes lecturer dia time variant. Student apa ni, let's say start, let's say a lecture supposed to be 1 hour. So the student came in late 10 minutes. So I only have 50 minutes to finish my lecture. So in order to finish at the same time that I supposed to finish, so therefore I have to compress by 10 minutes. So that is the time variant system. So I am a time variant system, not time invariant system.
Yes, sir, betul.
Okay. So time invariant, if you delay 10 minutes, the result also delay 10 minutes.
And 10 minutes later.
Yes, later. So, example. If the system y of t is equal to k x of t, which k is constant, is it a linear system? Is it a time invariant? So, you need to do a test of linearity. What is test of linearity?
Jangan dia linear kan?
To test the linearity is basically that x of x1 will produce of y1 and x2 will produce of y2. So x1 will produce a y1 equal to kx1, x2 will produce y2 is equal to kx of 2. So x is equal to ax1 plus bx2 will produce y equal to k of x equal to k times ax1 plus bx2. So ak of x1 plus bkx2 equal to ay1 plus by2. So the system is linear because ax1 plus bx1 will produce ax1 plus by. So that is how you do the test of linearity. Time invariant. If you want to test the time invariant, so basically that you introduce the delay in the equation. Okay. So x of t equal to x of t will produce of y of t equal to k x t. Okay. Basically that this actually you take the original formula. Then after that, if I introduce the delay in x, is it the same? Is it produce a delay in y? So let's say then I produce k of that. I mean t minus tau introduce a delay in the output. So is it the same? Is it produce the same delay? The answer
Yes,
is
sir.
yes.
Yes,
So
sir.
therefore the system is time invariant. Okay. To test the linearity, basically that you introduce the constant. This
One output,
this
one.
this. Then you this. Then you do the math. Example number 2. If you have a system, this is the system. Y of t is equal to k1 x of t plus k naught, where k1 and k naught are constant. Is the system is linear or also time invariant? So you want to test the linearity. Take this. X of 1, you have this, and another signal x of 2, similar function, and of that. Then assume x is equal to ax1 plus bx2. So therefore y is equal to kx1 plus k naught. So you take this, masukkan the equation, and you do the math. Do you get the same thing?
No.
So you will not get this same thing. You will not get the a2. So therefore the system is not time invariant. You introduce the delay in the input. Okay, so you introduce here. So do you get the same thing? T minus tau? Yes. So the
Yes,
system is
sir.
time invariant. Yeah. So in summary, so basically that we have covered the type of signals, the type of the operation, the basic functions of the signal, and we have covered on the what do you call it, type of system. So type of signal, we have what do you call it, analog versus digital, vector is deterministic versus random, periodic and non-periodic, and odd versus even. Okay. For basic function, we have unit impulse, which is represented by delta. Then we have step function, this step function, which is represented by u of t. We have another one. It's not here. Good.
Sinusoid.
Function,
Sinusoid.
RAM. Unit RAM. ramp function. Okay. Ramp is R of T. Another one was not in here.
Sinusoid.
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 Yes. Right. Sinusoid and okay. So we have
6.
1,
6.
2, 3, 4, 5, and 6 basic function. For signal operation, what do we have?
Shift.
Shift.
First one, shift.
Shift.
Second one,
Reverse.
reverse.
Scaling.
Third one is scaling. Then the fourth one,
Tiga-tiga.
combination. Combination. Okay. So type of signals. Remember, L, T, I, C. L is linear. What is linear? Basically that you have to do this test. AX1 plus BX2 will produce AY1 plus BY2. Causal,
No input, no output.
yes, no input, no output. So no future value. So x of t equal to 0 for t greater than t naught, less than t naught. And ti is basically time invariant. Shift in x will produce shift in the output. Okay, with the same amount of time shifting. Clear, simple.
Clear, sir.
So this is the
Yes, sir.
habis for the lecture number 1 actually.
Yay.
Yahoo! Tingo.
Okay,
So
sir.
now we go into we go into the second lecture,
Okay, sir.
second chapter. Huh? Take 5. Okay, so I stop apa ni recording first, then after that we go into the second lecture and I will record semula. Stop first.
Baik, sir.